Welcome to Ladyada.
Hey everybody, and welcome to my desk. It's another Sunday night, hacker o'clock, time for me to chat about what's going on here at Desk of Ladyada. I don't think there's any news for Mr. Ladyada, right?
No, we're going to have a full week of shows and more. All the schedules are up, so you can check out the Discord show schedules and more.
Yeah, last week was short, but this week,
yeah,
most things are back
and
to normal.
lots of fun surprises and more this week. So let's kick it off. What do you want to talk about first?
Well, let's go to the computer. I'll just show off this great search we did back in March in the before. I got totally crushed by revisions. We easily did like 25, 30 revisions of boards, and there's more to come, but I actually got to the point where the board revisions I'm doing now depend on me actually finding new components. So I've kind of like shifted back to trying to get more breakouts done so I can test out these new alternative components. So one component that, ironically, at the time we couldn't get the List 3 MDL, which is a triple axis magnetometer that we use for a lot of our IMU breakouts and also the Clue and the Feather Sense. It's a great magnetometer, but when we were buying it before, it was like $1 or less, and now the price has tripled, basically. We can't get it at a good price anymore. And you don't want to increase the price of the Clue or the Feather Sense by $5. I'd really prefer to keep it at the price it is because everything else got more expensive. A while ago we checked out the MMC5603, which is a very tiny magnetometer, but as you can see has tons in stock at DigiKey and others. And it's a very simple sensor. It's fixed rate, although it has pretty high data rate. Sorry, it's fixed range. 30 Gauss, which is plenty. You don't want more than that. That's plenty to do, Earth magnetic field detection and, some basic magnetic field detection. It's also 20-bit, which means it's pretty high resolution. Yeah, the I2C interface, I was playing with it this weekend, because I finally got the prototype together. It's got this annoyance that I've seen sometimes where the I2C has write-only registers, which drive me a little crazy because it's like you have to cache the bits before you write them. So the driver's a little annoying, but despite that, it's not a very complicated sensor. It's pretty easy to get up and running. And I've got a little breakout here. So let's go to the overhead and I can show off this breakout. And I'll talk a little bit about my workflow. So this is the breakout and like this little sensor in the middle. It's a 4 BGA. But you know what? It wasn't too bad. Like I made 2 prototypes. One came out, one didn't. BGAs are a little scary. On the other hand, because they have the solder balls, it's okay if your paste deposition isn't perfect because the solder ball, solder comes with, so it melts into place. And the XYZ axis, I made the same as the List 3 MDL breakouts. This is kind of drop-in replacement. And then one of the things I'm trying to work on is how can I optimize my driver writing workflow, because I write a lot of drivers and I'm just so busy with so many revisions and there's so much stuff going on. I want to make sure that I can write the Circuit Python driver and Arduino driver very quickly. And so I experimented with a different way of doing it this time where I use an FT232H, which is a USB to I2C SPI/GPIO converter, and it's just nice because it's got a Stemma QT and I just plug it in, and then instead of writing the code on like a Feather M4, I'm actually writing it on my desktop, and it's actually there's pros and cons to that. One pro is I can clone the GitHub repo directly to my computer and then I'm writing code. It doesn't have the fun auto refresh that CircuitPython has. I know you can kind of do that with shell scripts and whatever cron jobs and whatever, but I just Control C and rerun it. So at my computer, so if you want to go to my computer, so I have under MicroPython I have all my libraries. So this is the Git clone from GitHub of the library, and then I can just open this up in my favorite editor, and I edit the code and I update it. And there's a couple of things that make CircuitPython is it is fast iteration. Even CPython on a computer is fast iteration. I'm used to writing the Arduino library first and then the Python code, but I'm actually going to experiment with writing the Python code first because I think it might be faster for me to iterate because there is like I did make a mistake in this code, when I first wrote it, and I had like the wrong, the byte array wasn't long enough. I had 8 bytes, not 9 bytes. And Python tells you, Python's like, hey, you are indexing into an array past the limit of the array. Whereas Arduino happily does it. It's like, hey, you want to keep reading past your memory pointer? Go for it. I will not stop you, which is, a pro and a con of Arduino and C, C++. So, I write the code here, and then I just run the code itself in the command prompt. It's not as nice as a shell, but, if I'm just running, Python, it's fine. So if I want to say, this example runs once a second and prints out the data, and I can shift this around. And if I want to speed it up, I can open up the example, and I just change the sleep to be 0.1 seconds. We run it, and now it's faster. So no less compile time, less upload time. So I'm gonna try this instead. The only thing is about the FT232H is I don't know if it does clock stretching, so I just have to kind of keep my eyes open for that. And and then porting into Arduino, I think one thing I've noticed is that Python, again, because you can just create objects, you can you don't have to do memory management and stuff. When I ported to Arduino, I actually did kind of line by line, and it was fine. It was pretty fast. So it only took me about an hour and a half to write the Arduino library, 2 hours to write the CircuitPython library. So this way, I get that full coverage of Raspberry Pi and CircuitPython and single board computers and CPython, and then Arduino, which gets you everything else.
Okay, one comment and then one question.
Yeah.
As we move on. For the drivers at Skirt wrote, they've done CircuitPython version first, definitely helped. Currently writing one for RTC. So it looks like that workflow is helpful.
Trying different things.
Yeah, and then next up, any progress on our ultra-wideband Featherwing?
Nope.
And or can you recommend a ultra-wideband eval board?
Yeah, the eval board that they sell is pretty cheap. It's a Shield, but you could wire it. Actually, I have the prototype, just the PCBs came in. Not that that means it's going to get done anytime soon, but I thought the next thing I'd do is just quickly go through the prototype PCBs before we move on. Yeah.
If you're using CPython, can you limit your resources to know if the memory will be an issue on the microcontroller?
No, but I kind of have a feeling.
Yeah.
I know the tips and tricks we use. I'm not too concerned about it.
Okay.
I'm not allocating a big. I'm not importing NumPy. I'm not allocating a large array. We've the tricks that we use to reduce allocations. I've well established. We use the register library to do register reads, which is a little memory intensive, but I'm not willing to restrict libraries to make them memory small. I've just sort of moved on past that. It's that's not important to me anymore.
Okay.
So yeah, let me go to the overhead, and I'll just quickly go through some prototypes.
Okay. As far as predictions on stock stuff, any S3 feathers you think are in the pipeline?
Well, we have the S3 feather and the S3 TFT feather.
Yeah.
Both of them, I think we were just waiting on S3 modules, and I think they came in. So
Okay, so those
there's no reason not to, but I just don't know when exactly.
Okay, so those are looking good.
I think it's fine. I mean, there's some components people are like, hey, when is this coming in? And I'm like, I do not know when we're getting that part again, but those are not part restricted.
Good. Okay, you want to do overhead for
Yeah,
showing
there's
what we
the
got
overhead.
here?
You can see I got a big pile of stuff. So I got my JLC PCB, so I can kind of just go through the components. I won't take them out of the bag. So this is the Gerber file. It's called Buddha, because Phil was making also 3D printed Buddha. So this is interesting. This is NRF52 TFT feather. So it's got NRF52, and it's got that magnetometer on there. This is kind of like a feather sense. It's got RAM, microphone, humidity temperature sensor, IMU, power supply stuff, and on the other side is the TFT USB user battery, reset battery, and so user and reset button and a battery. So kind of like the ESP32 TFT boards that I made, but with an NRF52840. Scott recommended it. He's like, I'm doing some stuff with Bluetooth. It would be great to do Bluetooth and have a little display. And the Clue does it, but it was like, maybe we could make a feather. So I whipped this up. Let's see. This is, this is a tiny OLED display. I don't know if I can show it, but this is like a little 64 by 48, I think, sized OLED display with I2C. It's going to be very tiny. And just went through actually a lot of revisions. This is a very old design that I just sort of keep forgetting about. But hopefully I'll get back to it. This was a request. Somebody wanted a Stemma QT hub board, so you could like have, Stemma QTs with 5 connectors. So this way you can, if you don't want to chain them, if you want to have them be a star pattern, maybe lower the capacitance or something. So this is that design. It's all passive. Let's see. This was a weird idea. I had this thought of making, a Stemma QT friend for driving NeoPixels. So this is like, a kind of an interesting board. It has a AT-Tiny 817 with I2C, and then, a 3-pin connector for NeoPixel out, and then a power in connector. So because the Stemma QT cables can't carry more than like 200 milliamps. So this could be interesting, like, I just want to, quickly put together NeoPixels on, like, I think it was because we had a couple people who were like, I want to drive NeoPixels on this weird-ass chip that it's not fast enough, or, it's a single-board length computer because you can't get a Raspberry Pi. And I was like, this maybe could be a little helper friend. I don't know. I whipped it together. This is older design. This is the HUSB. So this is a USB-C PD device. It's an interesting chip that you can set the current with resistors. There's little jumpers here. Or you can use I2C. So there's a little breakout down here. You can connect I2C. If you want to like change the USB VID, or like configure the voltage and current over I2C. I just thought it was interesting, so I made a little breakout for it. This is a PC joystick to Stemma QT adapter. PC joysticks are weird. I think we covered it like a couple weeks ago because they use, obviously they have 2 analog inputs and then GPIO, and then the analog inputs are actually like rheostats, not potentiometers, and so there's a couple passives here, but I have to get that connector that we spec'd a couple weeks ago, get on order, and then this shouldn't be too bad. It's just GPIO and analog reads, but a good thing for a Stemma seesaw board because it requires both analog and digital in. This is also an older design. This is sort of like a little joypad, also with a seesaw and Stemma QT. I do projects sometimes and I need like a gamepad input, and I'm like, I don't want to wire up like 8 buttons. So this is just, be a simple I2C with analog and 4 pad and then start select. So, if I ever make little games, it's a quick way to get them up and running. This is for the GUV-C. This is a Genicom UV-C sensor, which it's I2C sensor, which I actually got. I think we spec'd it a while ago. And it's just so hard to get UV sensors. I know like we keep introducing them and they get discontinued, but hopefully this one will stick around. Genicom makes a lot of UV sensors, so I think they'll keep it. Okay, so I redid the Metro Mini. This is actually kind of interesting because this board, it's a Metro Mini, and I had to, so we are going to get some Atmega 328s, but I wasn't sure we would. And so I was like, while I'm at it, let me like redesign the Metro Mini to like the Metro Mini V2. So it's USB-C, and it has a Stemma QT connector, and then a couple of the little parts just like tweaked around. And it's also using a smaller QFN chip. I was able to get like a couple hundred of these QFNs. So it's basically pin compatible and chip compatible with the Metro Mini, but USB-C can use the WCH9102 because again, like CP2102s are impossible to get, and I like the Stemma QT connector because honestly, I might just build this. Even if it doesn't go to the store immediately, I'll build a prototype because I'm always using a Metro Mini for testing out my sensors. So very handy, less wiring for me. ENS 160, it's a little breakout for this funky package. It's like 3x3 pads, square pads. This is an environmental sensor. I don't remember the company. It's not Sensorion, somebody else, but it's a, it's like it's alternative to the BME 688. I think it does like gas sensing as well as VOC sensing. This is the ultra wideband feather somebody was asking about. So the feather wing, just PCB came in. Haven't put it together, so it's still shrink wrapped, but maybe one day. And then finally, the AD5693, which I believe is a DAC. I actually don't remember what this was. I think it's a 16-bit DAC, or maybe, I think it's like a high resolution DAC. Most DACs are like 10, 12 bits, and so I think this is a high res DAC. I don't remember. A lot of prototypes. All right, so that's my prototype pile.
Okay.
Not out yet. Don't ask.
Yeah, so these might be don't ask, don't knows.
Don't ask.
But this might just be some friendly advice.
Yeah.
Is there a reason to keep trying to design around the S2, or should they focus on the S3 since the S2 modules are going to end at some point?
The S2 module is not going to end. They're going through an ECO, so they're not discontinued. They just made a little bit of a fix. I think they improved the RF performance, so they're definitely still around, and they're coming out with a Rev 2 that's pin compatible because I asked them about it, and that's not a problem. Whether you want the S2 or the S3, I mean, there are trade-offs. The S2 has a DAC, the S3 has a TFT driver, the S3 uses more power because it's got dual core, the S2 is a little bit more mature. I don't think there's any, I mean, if you use the modules, they're essentially pin compatible, so use whichever one you like. But,
I could answer this one. Any plans to make an RP2040 with the module that Pico W uses? Bluetooth Classic would be nice on a feather. Just came out. We're looking at. Not sure.
Yeah, we don't have. Raspberry Pi would basically have to release the module. Like, we don't have that access to that chip, and they do. And so it'd be cool. Maybe one day they'll make a module. I think it would be great. But for now, just use the Pico as is. Note that Bluetooth Classic support isn't there quite yet either for that module.
You noticed JLC PCB shipping pricing has increased.
All pricing has increased.
Everything's
more
Nothing's
expensive.
gotten cheaper.
Nope.
Except for
love is still free.
Yeah, human life. It's the only thing that's gotten cheaper. Okay.
Let's do the INMPI.
We have INMPI
and we'll do the great search.
And we have great search.
Okay.
So let's.
We have to catch up. We're 1 week behind.
Yeah, let's kick it off.
INMPI.
All right, INMPI this week brought to you by DigiKey and Adafruit. INMPI is when we look at the latest and greatest cool stuff and more on digikey.com. This is Jonard Tools. This is one of their graphics. I grabbed that from Twitter. What did they make, and what is this week's INMPI that is on DigiKey?
Okay, so last week's INMPI was physically big, so I did the office, but this one's physically small. So we thought we would do this from the desk of Ladyada. So this week's INMPI is the Jonard micro deburring tool. And so, deburring tools are not new. I know you've probably been like, I've seen these before. Why is this an INMPI? But I remember the first time I saw a deburring tool, I was at the Media Lab, and Saul Griffith was showing me, I drilled something out, and I was, trying to file the hole or the cut, and he was like, that's going to take forever. It's a pain. You have to, jig it. You have to hold in the vise, and you're going to mar it. The best thing to use is to use a deburring tool. And he picked this up and handed it to me, and I was like, he showed me how to use it. I was like, oh my God, this thing is so cool. So I do recommend, if you don't own one, it's a good idea. They're only $20 and they are super useful. So a deburring tool, this is, I've just grabbed the graphic. Basically, it's this curved S blade that sits in a ball bearing and it's got a nice handle. Traditionally, they were used for cleaning pipes. So if you're a plumber or an electrician and you're cutting conduit or copper pipe or PVC pipe, you cut it and there's always little bits and pieces and burrs left over from the cutting edge. And you use a deburring tool to clean up, especially if you wanted to fit pipes together and you wanted them to be flush, or you wanted to glue things and you didn't want to have any, as my parents would say, schmutz in the way. So this is what a deburring tool normally is used for, but it's also used for, and this is a nice demo. It also can be used for other stuff like 3D prints and PCBs, especially when I was making PCBs with copper etching. I would laminate and then copper etch with ferric chloride or copper chloride the copper off, and then I would cut the PCBs down with I can even show them my diagonal cutters, my sheet metal cutters. They always leave like kind of a gross burr at the end, and I would use the deburring tool to clean it up and make it nice and pretty. So it's pretty easy to use. You just grip with your hand. It's nice because you don't have to use a vise, and you don't have to jig your tool. So it's like, especially for round stuff or delicate stuff, it doesn't get hurt. And then you just kind of do this elegant swiping motion, which I'll show you. It takes a few moments to get used to it. If you've never, the first time you'll get stuck, but just practice it for a minute or two, and then you'll have beautiful deburred outputs. And then I found some photos of, because I was like, can I find any photos or videos of people deburring? Turns out there aren't any. I mean, I'll show it live, but I did get this nice picture. This is an amplifier. Actually, can you look at the next picture? I think I swapped the two pics. So this is like an amplifier I saw on Flickr. Somebody, they printed out this template. You paste it on top of a box, and then you use a hole saw or a drill to cut through. But you see how, if you go back the previous one, it's all really rough. This is exactly where you would use a deburring tool. You go in and you just scrape away, and it's like so satisfying. You scrape away all those burrs, and you get like a beautiful, slightly countersunk finish. And then don't forget also to pick up extra blades. The blades do go dull, especially if you're using them on metal. You can use these deburring tools on brass and copper, mild steel, not stainless steel. Aluminum is fine. Of course, all sorts of plastics. Won't work on glass. Anything kind of soft. Foam is too soft, but maybe modeling foam is okay, like the kind of firm stuff that you would use with your Modella or your CNC. Not super hard stuff, but like the kind of firm stuff, and of course all sorts of woods as well. So also I did want to shout out, while after you book your order on DigiKey, go check out the Jonard Tools TikTok, which is filled with really good videos on how to use hand tools, and like details, and they answer questions. You can ask them questions about their tools and they'll answer them as well. But for now, I thought maybe before we pop over the video, I could show a live demo of this tool. Let me make sure I'm okay. Good. So this is the handle. I'll say the handle does not open. There's some tools I've seen that the handle opens to hold the blades, but this one doesn't. To change the blades really easy. You pull this down and this releases. To reinstall, you pull it in and it does a nice click, and then this moves freely. So for example, this is a nice 3D print, but let's say you had a burr edge on the 3D print. I like to put my thumb to support it, and then you can just scrape to create a nice edge. You can see like it's giving me a nice, much smoother, non-sharp edge. And this is resin, so it goes from having like a nice sharp edge to a nice smooth edge. The other thing I use it for, hold on, it's to clean up the edge. Also, you can see this makes a nice clean, smooth cut, and you'll get a smooth deburring edge, and then you can go the other direction as well. So a nice little tool. Definitely easier than sanding, especially if you have stuff like plastic that you can't sand, or it'll gum up your sandpaper or your file. This doesn't gum up because it's got a blade on it. And then finally, not recommended, but something I do. But again, if you're doing this, make sure that you are doing it with a vacuum or over a trash can, is if you have a hole, like I had holes in my PCBs that were mounting holes that were too small, you can go in and like very carefully, you can either countersink them or enlarge them. Not what it's supposed to do. It's not meant for fiberglass, and of course you want to clean up the fiberglass dust real well, but I have done it. It works, of course, better on paper phenolic. For paper phenolic, it works great. So sometimes if like I'll mill a shape or I'll cut a shape and I need to have it be a little cleaner or a little bit bigger, I'll go in with the deburring tool as well. So deburring tool. This one's mine. I actually bought it for myself, but also a great INMPI.
And that's this week's INMPI. Do you want to play their video?
Yeah, let's play their video because
Let's do that.
they have more
Yeah,
details.
I should say, available on DigiKey.
They have some in stock.
There's a few left in stock, so make sure to get it. And we're going to play this video and see you on the other side in 2 minutes.
Hey guys, Ed here from Jonard Tools. Today I want to talk to you about one of our latest new products, the DB-5. The DB-5 is a microduct deburring tool. This tool is perfect for prepping the inside of microducts for termination or connectorization. The tool features the following: a high-speed steel blade that has 0.71 inches of cutting edge. S-shaped design makes it nice and easy to use. Ergonomic rubberized handle, which gives you comfort and good secure grip. Easily removable blade. We sell replacement blades. The replacement blade part number is DB-5RB. Simply pull the collet down, insert the blade back, listen for the click, and the tool is ready to go. Let me show you how to use it. Simply take the tool, insert it into the duct, rotate several times. You now have a nice clean chamfered end. Doesn't matter the size of the tube, it'll work on something very small as this as well. And you can see a nice edge on it. This tool will also work on PVC pipe, high-density polyethylene tubes and piping. It will also work on steel, copper, and aluminum conduit or ducts. Thank you for watching our video. Please take a moment, like, share, comment below, subscribe to our channel to see the latest videos from Jonard Tools.
Alright, so you want to roll right into the Great Search?
Yes.
Okay, Great Search coming up.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search. Every single week, Ladyada uses her powers of engineering to help you find the things you're looking for on digikey.com. Ladyada, what is this week's Great Search?
Okay, so this week, sorry, I was just putting all my deburring tools away. This week's Great Search is a request by a customer. Hold on, actually, let me get the right. Oh my God, we have so many products. Okay, so this is a request by a customer, somebody who had a bunch of LED matrices, and they said, "Hey, on the back of the matrix is this power connector, and you have these connectors that you sell, but I want to get that connector itself. And do you know the part number?" And it's like, somebody even made the joke. They're like, they're always called Molex connectors, but these are 0.2 inch spacing connectors, and they've got this kind of funky latch. Let me see if I can. We also sell the individual cable, so I'll show you what the latch looks like. So the question is, like, how do you find that matching cable, power cable? One moment. Here it is. This particular latching, arrangement. How do you find the exact connector when it's just like, whenever you buy the matrix, you always get the connector with it. And so I thought, well, let's try to figure out how to find a similar connector. I think this one, I posted in the forum and I answered them. But let's try to figure out how to get this connector. So having measured it, it's I know it's 0.2 inch spacing. So this is called, like a rectangular connector. And they're always called Molex connectors, but they're not necessarily made by Molex. Let me turn on the beta because that way you can see images. So rectangular connectors, the closest one is going to be like this, although this is free hanging in panel mount, but I think I went to this one. Yeah. So this, actually, sorry, I think I want the free hanging in panel mount. Let me see these images. Yeah, I think this one's closer. Okay, let's try this one. If it doesn't, we'll do the other one. So this connector is 4 pins, 1 row. So let's do 1 row, 4 pins, and let's apply, and let's see what we get. Okay, cool. Yeah, now we're getting, actually I don't know if it's this category or the other. Oh, this one's getting kind of close. Okay, so let's also look for active, because we only want to find stuff that's around, and we want free hanging and inline, because we want it to be, it's like this loose cable, although is it? Now I'm not so sure. I think actually I do want to be in the other category. Yeah, I think I do. I'm sorry, it's not free hanging because it connects. It's not free hanging because it connects back to the PCB. So I actually do want rectangular connectors. Sorry, pretend I didn't do that. That's what it's like searching. Okay, try again. Number of rows, 1. Number of connectors, 4. Active. And then apply. Okay, yeah, now we're getting closer. So this is not too far away. So the next question is, I wanted that little like hook latch thing, like this, because this is a very unique element. And so this was called a latch holder or latch lock. It seems like there's both kinds. So I want to add that on. Actually, let me do the pitch next. So I think this was 508.2 inch. You can, of course, measure with your calipers. And yeah, so we had a couple of good options here. So then, again, I wanted to get something that was latch lock or latch holder. So let's look at latch lock and latch holder. Locking ramp is a little different. Locking ramp, there isn't a little piece that you don't you press it down to release, like, and it bends out rather than lifts up. And then let me see what else. There's receptacle versus not, free hanging. And then let's look. Okay, so then this actually wasn't too bad. Now this is actually where I started looking at the photos. So this is not, this has I think this is like a friction lock. This one seems really similar. This one does not. This one does not. So I actually just kind of went through and I looked at them all because there's only like 20. Like, this was actually kind of a cool connector, but also the wrong kind. And in the end, this is actually really close. Now remember, this is just the connector, not the cable. So when I looked at this, I was like, okay, it's got like the little leggies and the latch, leggies and the latch, and then this is like nice and rectangular and slim. Looked good, and you'll need the crimp connectors as well. So this is in stock. So I would probably pick this up. Now I did tell the person, we sell the cable. You're better off taking a cable and cutting and splicing it. But if you do want it, you can get also the matching connectors they have here. And then in the data sheet, they'll often, they do not tell you. You can take more measurements, but they'll sometimes tell you the contacts. Economy power seems likely. Under economy power, go to contacts, then you'll see the matching. It's part of the same series of connectors. So you'll see the crimps here for socket 10, 22 to 26 gauge, and then 18 to 22 gauge. So that makes sense. I think, like, if I was going to be making these RGB matrices and I want an economic power connector, I'd use the TE economy power. And then don't forget also, they're expensive, but if you're making a lot of these cables, get the crimper. If you're not getting the official crimper, at least get a standard crimper. Do not use pliers to crimp. But other than that, this I think is the best bet. So I think this is the connector. I'm actually going to try to contact the factory that makes these RGB matrices and ask them, because like maybe they do have. The problem is oftentimes the connector that they're using is like a knockoff part number that has some basis in an American or European company, but it's like 3 generations down. I've seen this with JST SM connectors. Like what you're getting often, it says JST SM, but they're not truly JST connectors. They're like clones of clones of clones of clones. So, but I think this is the closest one to match. So I let them know, and they're going to try it out. I'm also going to maybe order one of these and just make, see if I can press fit it on, see if it fits onto the connector, and the little latch thing clicks into place.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okay, and I think we were going to show one last thing, the Copilot thing, right?
Oh, I forgot to log in, so no, I don't.
Oh, yeah?
Yeah, sorry. Maybe we'll do a video during the week.
Oh, got it. Well, let me just tell everybody
Let's
about
talk about it. Yeah,
Yeah,
I also forgot. 'cause we
So
had so much going on.
here's the thing. Everyone has an opinion about Copilot, or they will. And basically the controversy side of this is you're a developer and you're using Copilot. You pay for it. It's a service. And it puts in code as you work on code.
Yeah.
Where'd you get the code from? Well, it was code that was on GitHub or maybe even other places. And there's probably going to be some type of court case to decide, were they allowed to do that or not? That's not how we are going to use it, though, or at least experiment. So one of the things that we're playing around with is we cut and paste our code in.
All the time.
And our code is definitely in Copilot because we have open source code. And we wanted to have it decide or say what is going on in this code. So instead of it writing new code, it looks at the code and it says in English terms, or more simplified English terms, here's what's going on. So that's one application of it. And the other one, library stuff.
Yeah, so commenting, libraries, Doxygen. I don't know. It could be interesting. A lot of our libraries are very similar. We use a lot. I mean, we don't copy and paste all the code, but the structure is very similar. So we're wondering if, I know that there's automatic, I've used IDEs that are like, they'll make all your setters and getters for you. But it'd be interesting to see if that could work within VS Code, using OpenAI or like GPT-3 or Copilot. So I'm going to try it out, and I'll see how it goes, and then we can do a little video this week maybe.
Yeah.
Could be interesting. I mean, I read open source code. I'd like it to train on my code base. We have like 1,500 GitHub repos.
What would be cool is an option for people like us to say, okay, use that giant AI machine, only pull from our code, and let us use that as a tool, because that'd be kind of cool. So anyways, this morning I was cutting and pasting in some of our code, and I would type explain this, and I put a chunk of code in, and it would say, oh, this is what you're doing with pins and LEDs. I actually gave a pretty good explanation.
Yeah.
So anyways, kind of interesting.
Stuff.
Okay.
Okay, I think we
did
it all.
That's it. We did
Okay.
everything. And that is Desk of Ladyada for tonight. Good night,
Jam-packed.
everybody.
Bye, everybody.